Can you all hear from me? If you can, please drop a yes in the comment section in the live chat that's publicly available. Let's try. Please let me know if there are any problems. Hi Satyam. If everything's all right, I can. Yep. Thanks, Satyam, for pointing it out. Just give me a minute. Awesome. Thank you. Thanks, Sanjeev. Hi, Sandesh. All right. So I'll start off. So hello everyone. I'm Sai Avinash. Hope you're doing extremely well. I'm an SRE at Google Dublin. My All India rank in CodeChef is 3. I'm a 7-star programmer there. My master at Codeforces. My max rating is 2373. I'm an SD. I previously interned at Uber, and I'm also snagged on finalist. The subjects that I take are mathematics, dynamic programming, and graphs. And if you're subscribing to the Unacademy Plus subscription, do use the code SciLife to get a 10% off. So, there are new batches coming up on Unacademy. One, Acme. It's a full stack development master course. It goes live on 27 July. It's a 2-month duration course. There's Lead 2.0. It's a system design course with real-world case studies. It goes live on 26 July. It's a 1.5-month durated course. There's Paramount 2.0. It's a backend development master course. It goes live on 27 July. So what are the Plus subscription benefits? You get to interact with India's best programmers, and you get to ask your questions live. Whatever doubts you have by practicing problems at CodeChef, you can ask them live. Or if you're learning any new concepts, you can ask them live with India's best programmers. Use the code SciLife to get a 10% subscription, 10% off on the Unacademy Plus subscription. So, every Wednesday night at 10 p.m., there's a lecture by Ash Goel, he's a senior software engineer in Samsung, about guidance for college students to make it big. So do try to attend that. And there's another course about cracking campus placements and IT jobs. As you can see, the offer is valid only till 28th July with a free personalized mock interview sessions by a group of educators. Do try it out. Additionally, there's Bugs Bounty. It's an opportunity for all learners to report any inappropriate content in the video. Be the first one to report a particular issue to claim your prize. It's good to have a nice platform without any inappropriate content so that it's healthy for everyone to learn and grow. Do report any inappropriate content using the form in the description. So, if you think this is going to be useful to you, the content that's going to come up that's going to be useful to you, do like, share, and subscribe. Don't forget to share it with your friends so that it's useful to a wider audience. So let's start off. So if you have attended my last lecture, you would have I gave you this problem in the end to solve. So if you made any progress on it, or if you've made any progress, absolutely any progress on it, do drop it in the comments. I'll keep an eye on the chat if there's any. Yep. So here's a solution. Here's a question. N is up to 10 power 12. You need to tell if it has exactly 3 divisors. How would you do it if there, like, how would you do it if there are no test cases? If there's only a single test case, how would you do it? I'm looking at the live chat. If you have any hints or if you have any starting points, let me know. How would you do it? If there's only one test case, not 10 power 5, there's only one test case, and it's up to 10 to the power 12, how would you do it? How would you tell if a number has exactly 3 positive divisors? For example, the number 6, the number, what do you say? I guess 25. The only divisors of this number are 1, 5, 25. Whereas the number 16, it has 1, 2, 4, 8, 16. This has 5 positive divisors, so it's wrong. This has 3. So this is correct. You just need to tell if a number has 3 positive divisors or not. How would you do it? How would you do it? Think about it. Sanjeev Kumar has an idea. Square root. What after square root? Like, how? Oh, I skipped a cuff there. What after square root? So Shubh Desai has a solution greater than 1, and it should be a square of a prime. That's absolutely correct. The number should be greater than 1, and it should be a square of a prime. Okay. How did you come up with that? Like, how would you, like, why square of a prime? It seems like out of nowhere. But let's see how it comes up. So we discussed in the last class, like if there is any problem regarding divisors or anything, we break it into its primes. We break it into its atomic parts, which is primes. Atomic parts in terms of multiplication. Yeah. So if a number n is there, if it has factors, if its prime factorization is p1 power a1, p2 power a2, p3 power a3, so on. It's the number of divisors this number has is 1 plus a1. We discussed that the number of divisors will be 1 plus a1 into 1 plus a2 into, I'm just revising what happened in the last class, 1 plus a3, so on, right? And how does this come? It came because the prime factorization is p1 power a1, p2 power a2, so on. I'll just take 2 power a1 and 2 power a2, so on. 2 power a1, 3 power a2, 5 power a3, and so on. The divisors would look, if n equals this, the divisors would look like, let's write it here, 1, 2 power 0, sorry, 2 power 1, 2 power 2, so on until 2 power a1. And then next, take another bucket, 1, 3 power 0, 3 power 1, sorry, I should be more, 3 power 0, 3 power 1, so on until 3 power a2, and so on. Right. That means in the first bucket, there are a1 plus 1 numbers. Second bucket, there are a2 plus 1 numbers. Third bucket, there are a3 plus 1 numbers. That's 1, 2 power 1, 2 power 2, so on. 1, 3 power 1, so on till 3 power a1, a2, sorry. 1, 5 power 1, 5 power 2, so on till 5 power a3. So you can pick any number from this, any number from this, any number from this, and you can multiply. For example, if it's 2 cube into 3 power 5, n equals this, n equals 2 cube into 3 power 5 into 5 square. We can take 2 square and 3 power 4 into 5 square, and this number will be a factor of n, right? Which means there are a1 plus 1 choices in the first bucket, a2 plus 1 choices in the second bucket, a3 plus 1 choices in the third bucket, and so on. This is like straightforward, and you just multiply all of them because you can take them one by one. These are the number of divisors. Now, if a number has to have 3 divisors, then a1 plus 1 into a2 plus 1 into a3 plus 1 into so on should be equal to 3. Correct? Yes or no? Any doubts so far? Any doubts so far? Yep, take you forward has answered, yeah, square root of n should be prime. Yep. That's absolutely correct. Now, yep. Now, if a number n is equal to say 49, it's 7 square and it has 3 divisors. Cool. Now, if you take the number 45, it's equal to 3 square into 5 power 1. How many divisors does it have? 2 plus 1 into 1 plus 1. It has 6 divisors. Okay. Now we have 49 is a nice number. 49 is a number which has 3 prime divisors, 3 divisors. 45 doesn't have 3 divisors. And let's take another number, 16. It is 2 to the power 4. It has 4 plus 1 divisors. 4 plus 1 divisors. So on. Okay. Now, we know that 3 is a prime number. Okay, something's going wrong here. We know that 3 is a prime number. Now, if a number is represented as 2 power a1, 3 power a2, 5 power a3, so on, and we know that a1 plus 1 into a2 plus 1 into a3 plus 1, the number n equals this. If n has to have 3 divisors, then this number should be equal to 3. Alright? Okay. The only way this is going to be equal to 3 is if a1 equals 2 and all a2, a3, all of them are 0, or a1 equals 0, a2 equals 2, a3 equals 0, and so on. Why? Because 3 can be represented, 3 is a prime number. 3 can be represented as only 1 into 3. That's it. So exactly one of these numbers should be equal to 3 and everything else has to be equal to 1. Meaning, some ai should be equal to some ai plus 1 let me rewrite that. A1 plus 1, A2 plus 1, A3 plus 1, so on, should be equal to 3. It means that some AI equals to some AI, like I can be 1, 2, or 3, and all the other AJ for J not equals to I should be equal to 0. For example, A3 can be equal to 2. That means A1 should be equal to 0, A2 should be equal to 0, A4 should be equal to 0, for all the other I. Correct? Meaning, only one prime should have its power squared. That is, to write it in mathematical terms, it means that n is equal to 2 power 0, 3 power 0. It can be like this, 7 power 0, so on. Or it can be 2 power 0, 3 power 2, 5 power 0, 7 power 0, so on. Or it can be some prime number. Basically, 2 power 0 and 3 power 0, all of them are 1. So I can just omit them. It can be either, it should be of the form p square. Alright, p square, where p is a prime number. Only then will it have the number of factors 2 plus 1 is equal to 3. Got it? Any doubts so far? I'm looking at the chat. Any doubts so far? Please, I'm looking at the chat. If you have any doubts, do ask them. I'll answer it right now. Shivans asks, if a square of a prime has 3 divisors. Okay, yeah, square of a prime always has 3 divisors, as we have checked. What are the 3 divisors if you want to write it out? The number p square, where p is a prime, the divisors of this number are 1, p square. For example, the divisors of 11 square are 1, 11, and 121. That's it. Now, he asks if the reverse is also true. Can anyone answer that question? Is the reverse true? It's a good question. Like, is the reverse true or not? All right. Turns out it isn't. Like, nope, it's not. Why? Because, like, take a square of a non-prime. 4 square. Okay, wait. What? I just misread this question. Okay. If a square of a prime has 3 divisors, Okay, if a number has 3 divisors, then it's the square of a prime, and the square of a prime has 3 divisors. Yeah, that's correct. That's actually correct. I'm sorry, I missed it. Yeah, that's actually correct. Yep. All right. So, what do you need to check? We just need to check if square root of n is a prime number. Prime. But before that, we need to check if n is a perfect square. If n is not a perfect square, then we're doomed. Like, we don't need to check anything. So first, n should be a perfect square. And square root of n should be a prime number. All right? Very straightforward. First, we'll check if n is a prime number. First, we'll check if n is a perfect square. Then, we'll check if square root of n is a prime number. Square. Cool. Satyam says the reverse is not true. What do you mean, Satyam? Like, can you elaborate? I'll check the chat. All right. Yep. So, how would you code this? How would you code this? We'll go step by step. First, we have to check if n is a perfect square. There are multiple ways to do this, like multiple ways to do this problem. If n is under 10 to the power 12, we know that square root of n is under less than 10 to the power 6. All right, if n is less than 10 to the power 12, we know that square root of n is less than 10 to the power 6. Got it? All right. Now, yes, Pawan asks, we need to run loop from 2 to square root of n, but first we need to find what square root of n is. Like, so we need a square root of n for that, right? So, assume that there are no test cases at all. How would you do it? I'll show it to you. All right. Now, bool check 3 divisors. Shivansh, yes, we can use square root function, but I'm trying to explain how the square root function works as well. Or actually, I'll explain a more simpler method. You don't need to use the square root function at all. All right. So int, it's long here. Long n. Check 3 divisors. Now, before that, first we need to check, is it a square? If it's a square, return square. Bool long. Actually, you need int. Square root is going to be int anyway. Square root of long n. One way is to just iterate from 1 to n. I'll just make this long just for convenience. I less than equal to n into n. I less than n. If I into I equals n, return I. Otherwise, return -1. So if I return -1, I know that there is no square root, like it's not a perfect square. All right. Okay. Now, long a is equal to square root of n. Now I just need to check square root of n if a is prime. Well, how does its prime function look? Long bool is prime of long n. This is very straightforward. We know this. How? Yes, Pawan Agarwal, we can do that. Yep. There are multiple ways to do this problem, as I said. Right? We can do that too. I'll show that method too. That's the method that I'm reaching to towards the end. Okay. All right. So for int I equals 0, I equals 1, I less than I into I less than n, I plus plus, if okay, I should be equal to 2. Yeah, because 1 is already going to be divisible by n. Equals 0, return true, return false, return true. This is the check prime function. We know this. This is going to work in square root of n. If is prime of a, return true, return false. First of all, if n equals 1, return false, because n is not a prime. Now, if a equals minus 1, return false. Why? If n is not a perfect square, we are returning minus 1. And if it's not a perfect square, it doesn't have 3 divisors. That we've already discussed. Now, it is a perfect square. We have the square root, which is a. Square root of n, which is a. Now we need to check if a is a prime. If a is a prime, we return true. Otherwise, we return false. That's it. Very simple. If there's only one test case, you can take long n as input. If check 3 divisors of n, C out yes, else C out no. Very straightforward. This is the brute force method. This is the ultimate brute force method. Let's look at the complexity now. Square root of n. The complexity of this is O of root n. Because we added it till root n, like approximately till root n. Now, is prime of a. You're iterating it till root of a, where a is root n. So root of a is going to be root of root n, right? So the overall complexity is going to be O of root n plus root of root n. I mean, we know that root n is already bigger than root of root n. So the complexity is going to be O of root n. Sumit says O of n. So, is that clear? Is this clear so far? Everyone, is this clear? Can you like drop a heads up about? Pawan says, I think I have not defined condition for n equals 2 in his prime function. What do you mean? I don't see any problem here. Can you point it out for me, please? Like, be more clear. So far, this is O of root n. Got it? Clear. Okay, thank you. You don't have to call me sir. So, yep. This prime should run from 2 till I into I less than. Yeah, that's what I'm doing, right, Sanjay? But is there a problem? All right, awesome. Got it. Yeah, but 2 is prime, but function will return false. No, I equals 2, but it won't go into this function itself, right? Because 2 into 2 is not less than n. 2 into 2 is 4. 4 is not less than 2. That's why this function won't execute at all. It will go here directly. Because I into I is 2 into 2 is not less than 2. Since I is starting from 2. So it won't go here at all. Alright? It'll go here directly, that's why it'll return true. That's correct only. No need to worry about that. Alright. Now, how do we optimize it? Pawan Agarwal had a correct solution there. How do we optimize it? This is the current solution is currently O of root n. We noted that n is up to 10 power 6, 10 to the power 12. Meaning O of root n we take about 10 power 6 operations. All right, it's cool. It's okay for one test case. But if it's for 10 to the power 5 test cases, 10 to the power 5 test case, for each test case, if you're doing this much, it's going to be really costly. It's going to be 10 to the power 11. But you know that our computers can handle only 10 to the power 8 operations per second, approximately. So 10 to the power 11 won't work. You need to be more quick about this. And how do you be quick? How do you be quick? So one method, there are two places here we can optimize, right? What is the bottleneck here? Square root of n, correct? Square root of n. Well, we can utilize the fact that square root of n is going to be from 1 to 10 to the power 6, correct? So what do we want? How do we want the answer to be like? Should be of the form p square, n should be of the form p square, where p is a prime, right? That's it. N should be of the form p square where p is a prime. Now, and we know that since n is up to 10 to the power 6, that prime which is there should be between 1 less than p less than or equal to 10 to the power 6. Since n is 10 to the power 12, sorry. N is 10 to the power 12, the prime should be from 1 to 10 power 6. Right? And we know how to calculate all the primes from 1 to 10 to the power 6. Very quickly. How? Using the sieve of Eratosthenes. It's quickly. We can do it in 10 to the power 6 log. Well, you can do it in 10 to the power 6 log of 10 to the power 6. This is approximately, it's going to be about 5 into 10 to the power 6 or something. All right, cool. All right, let me code it and I'll show you. Like, I'll explain it to you through code, and then you'll understand it more clearly. All right. So Sumit says divisors of prime factorization. Divisors of prime factor. Yes, you can do that. You can do that. You can just directly calculate divisors using prime factorization, but that will be a bit tricky because n is up to 10 to the power 6, and doing prime factorization up to 10 to the power 6 for all 10 to the power 5 test cases, it's going to be a little costly, isn't it? So for this problem, we'll approach it in the reverse direction. It's the square of a prime. All right. So we first calculate the primes from 1 to 10 to the power 6. We'll add all its squares into a set. Like 2 square, we'll add it into a set. 3 square, we're going to add it into another set. So on till 10 to the power 6 square. Like all the primes up to 10 to the power 6. Now, once it's in that set, for each test case, like we'll do this before we are taking the input itself. For all primes from 2 to 10 to the power 6, we square it and add it into a set. We have a set, we have a bucket. Like 2 square, 4, we add it into the set. 3 square, 9, we add it into the set. We put this all these numbers into a bucket. Now we'll go through each set, each test case one by one. And we'll check if the number is in the bucket. If it's there in the bucket, then it has 3 divisors. If it isn't there in the bucket, it doesn't have 3 divisors. That's it. Because all the numbers that are there in the bucket are of the form prime square. Correct. That's it. That's what I'm going to do here. Shivansh is saying I have to go from instead of going to n, I can go to root n. This is just another way to go to root n. I'm still here as well. I'm going to root n only. I into I less than n means I less than root n. Right. This is another way of writing it. Nothing else. I'm still going till root n itself. I is going to root n. If you look at it closely. I'll code the solution. I just code the solution. I just yeah. So first, as we discussed, set long my bucket, yeah. first I won't take the input. Like first I'll see what all numbers should be there in my bucket. Like what are the good numbers. So first for that I need to do sieve. How does the sieve function look? Void sieve, prime sieve. Let me know if there are any doubts. I'm constantly looking at the chat. So if there are any doubts, I'm here to answer. Prime sieve. And we need to compute for all primes up to 10 power 6. Cons int max 1e6 plus, I'll just write small 5. Vector bool. So I'll just use our bool. This prime. Max n. So what did we discuss? For int I equals 1, I less than equal to max n. Swaroop, it's getting hard for me to do CodeChef questions which involves or. I'll get to those topics later. Like, it's okay, we can go step by step. Initially, a lot of them would seem hard, but Zor questions usually are like a few observations of. You need to break them down into bits and you need to observe a few things and it'll be all right. Don't worry too much about it. Like, it's okay if you don't get it at the start. You'll get it through practice. If you want, I can take a few classes on it later. But for now, let's focus on math now. Math is very important. For int j equals. Never mind. Is prime of I equals true. Now, first we mark all of them as true. What is prime? What is prime? How do we do prime? Sieve. We mark all of them as true. Then we mark is prime of 1 equals false. Now we go from 2. I equals 2. I less than I into I. We can just go to the root of max n, right? As we discussed max n. Like I'll just write int limit equals square root of max n. Fine. I'll just that's one way. This is another way. Actually, I'll do it this way now. Like just so that it's easier. I into I less than max n. I plus plus. I into I less than max n means till I square is less than max n. Meaning if you take square root on both sides, it's I less than square root of max n. If I is prime, for int j equals I into I. We're going from I into I. We can go from 2 into I, but we can go from I into I as well because I into all its smaller numbers, I into I minus 1, I into I minus 2, all of them have been marked by lower primes already. So you don't need to do that. J less than max n, j plus equals I. So here I'm iterating through multiples of the prime number. All the multiples of the prime number which are not the prime number. And I'm doing it a bit lazy here. I don't have to do it till, I can do it till 2 into I. But I can do it from I into I as well. That's still okay. Both are equally correct. But this is going to be a little faster. This prime of j equals false. Now, at this point, I just do a small modification. Not modification exactly, like, what after this point? Thanks, Shivansh, for your kind words. So at this point, after completing all of this, is prime is a Boolean array in which some numbers are set to true and some numbers are set to false. Like we're setting all multiples of primes as false, except itself. Some numbers are set to true. So the numbers that are set to true, like its prime of 2 will be set to true, its prime of 3 will be set to true, but its prime of 4 will be set to false because 4 will be set to false because of 2. 2 is going to set, since you're starting with 2, 2 is going to be prime, and you're going to set for all even numbers other than 2 as false. Similarly, if I is 3, so we're going to set all numbers that are multiples of 3, except 3 as false. Alright. Awesome. Now, like when we go from I equals 1, I less than max n, I plus plus, if it's prime of I, at this point, we know that I is prime. Right. At this point, we know that I is prime. Now, we add insert I into I. All right. We insert I into our bucket. Like we insert squares of all primes into our bucket. This is a set. If you don't know set, or if you don't know STL or something, you can check out Raj's course in the other STL video. Like he's explained it really well about primes and about STL and sets and vectors and so on. So you can check that out. But for now, if you know set, that's still sufficient. Sets STL. We can insert squares of all primes into this bucket. Like let's just revise the basic of a set. Like what does a set do? A set, it's just a bucket of numbers. You can insert a number, like you can insert 2, you can insert 3, insert 4. You can insert about a lot of numbers, and then it'll tell you, you can ask it, is a number present? Is a number 6 present? Is the number 6 present or not? Is the number 7 present or not? And it won't iterate through all the numbers in the set and tell you if it's present or not. It uses some data structure, some magic, like you can call it magic, and it'll tell you quickly, instead of in O of n, it'll tell you in O of log n, O of log of the bucket size of the set, if the number is present or not. So set is used for quickly answering if a number is present or not in the set. That's it, the set data structure. There's a bucket, you're adding numbers or you're removing numbers. You can quickly tell, I have a number, you want to tell if the number is present in the bucket, but there are a lot of numbers. You can't iterate through all the numbers, that's going to be slow. Set does some magic and tells you quickly if a number is present or not. You can add numbers to the bucket and you can remove numbers from the bucket. That's the main use of the set. Now, yes, power 1 is right. Using find, we can just check. If my bucket dot find n is not equal to my bucket dot n, return true, return false. It is as simple as this. Now there are 10 to the power 5 test cases, right? Int t, we take int t for int t equals 0, t less than t. Yeah, we are just taking this for each test case, long n. If we take the input, if check the 3 divisors of n, see out yeah, else see out no. All right. So what did we do here? Oh, first we need to do the pre-computation first. Prime sieve. All right. Yep, Harini says so interesting. Thanks, Harini. Yep. So what did we do here? We did the usual prime sieve that we talked about in our previous class. We calculated all primes. Calculate all primes. Now, for each prime, we square it. For 2, we square it. 3, we square it. And all these numbers, okay, my phone is lagging for something. For all the primes, 2, 3, 5, 7, we have a bucket, okay. Instead of water, we have numbers. And we put 4 here, we put 9 here, we have 25 here, we have 49 here, and so on. Up to the largest prime, up to 10 to the power 6. I don't know what that number is. Some number p. We have p square. All primes less than 10 to the power 6, we have its squares inside the bucket. And we know that all numbers under 10 to the power 12 who have 3 divisors are going to be present in this bucket. And only those numbers are going to be present. So, when we want to check if the number has 3 divisors or not, we just check if that number n is present in the bucket or not. If it's present, then it has 3 divisors. If it's not present, it does not have 3 divisors. That's it. Shivansh asks what sieve means. Sieve is it's an efficient way to calculate what numbers are primes and what numbers are not primes. There is some lag. Sorry guys, I had a small internet connection issue, so apologies for that. So I'm using the Sublime, and Pawan is right about Sieve is a pre-computation technique which generates all the prime numbers up to 10 to the power 6. Like it generates all the prime computation, all the primes up to 10 to the power 6, all the primes up to n in n log n, n log of log n. So this is n log of log n. It might not seem so. The calculation for the complexity might be a bit complicated, and you don't need to know that. For all practical purposes, it's O of n into some small constant, which is okay. I'm using the Sublime text ID. All right. Is that still lag? I'll just switch off my I'll just switch off my YouTube so that. I'll just open my I'll just open my phone so that I can see the live chat. Yeah. So I'm using the video ID Sublime Text. It's a really lightweight editor with a lot of functionalities. All right. Cool. Someone is thak gaya prime pढ़ते. Dude, primes are a really important topic. Like I can't stress the importance of primes. Like that's the only reason I'm going through it so much. It's like the periodic table in chemistry, or I mean, you need to study. They're not just the elements of the periodic table, but the properties and what it can do. So it's really important to study primes and what you can do with it. I can't stress the importance. For doing well in number theory, you need to be good at primes and divisors and so on. You need to have a complete grasp over it. And that's what I'm trying to give you. It's not like I'm doing it for some. I'm not like telling it just for like I know it well, so I don't want for no reason. There is a reason why I'm telling it to you. So I request you to please follow it because it's going to help you. Yeah, it's like the carbon of organic chemistry. Yeah, you can see that way. All right. So any doubts so far? Any doubts so far with this? Do ask me. Also, in the next, in maybe 1 or 2 classes later, I'll start with combinatorics. So that's coming up too. Like I'm not going to teach you primes forever. Like combinatorics is coming. That's too much fun. So I'll go there too. But is there any doubt in this? Are there any doubts here? Please let me know. Time complexity of finding an element in the set. Time complexity of finding an element in the set. So a set is it's a balanced binary search tree, and for finding an element in that set, okay, I won't go into details, but if the size of the set is n, in this case, the size of the set is about max n. Actually, it's max n by log of max n because the number of primes under n is n by log n, but you can say the size of the set is max n, about 10 to the power 6. And to search in the set, it's O of log of max n. That's about log of 10 to the power 6. Size of finding an element in the set of size n is log n, simply. Removing an element is also log n. Checking if an element is inserting is also log n. That's it. Only size is O1. Like you can ask what the size of the set is and it'll tell you quickly. All right. Any doubts? Shall I move on to the next question? Do let me know if there are any doubts. Raja is asking me to execute it once, while I really want to execute it, but there are going to be a few compilation errors here and there, but I would prefer not to execute it. Like, yeah. But I hope you're convinced with the logic. Yeah. If there's any part of the code which is confusing to you, let me know. Like executing would take me time to debug if there are any compilation errors or any tiny errors. The logic is what's most important. So, I mean, I don't want to waste your time or something like that. I hope it's clear. All right, Noobbot is asking me to go to the next question. All right, I'll go to the next question. All right. Next question is a really tiny modification to this question. Yep, it's just tell if it has exactly 5 positive divisors. I won't take a lot of your time here. Tell if a number has exactly 5 positive divisors. Now I want you to answer this question. I want you to answer this question. I won't answer this question. You answer the question, and I'm looking at the live chat. Before we have, there's only a tiny difference. The previous question was if it has 3 positive divisors. Now, how will you check if a number has exactly 5 positive divisors? Tell me quickly. I want the answer quickly. I want it for 10 to the power 5 test cases. I won't take a lot of your time on this question. Shivam Singh has a good answer. We'll maintain one count, there we can check. What do you mean by that, Raja? All right, I think we already have an answer. So I guess it's very straightforward. Now, the number 5. Let's look at the prime factorization. Sorry, I'm using the word primes a lot. I'm using it only because it's really important. So if n equals a1 power, n equals 2 power a1, 3 power a2, so on, 5 power a3, so on. Now, the number of divisors that the number has is, positive divisors the number has is 1 plus, we know this, we already discussed 1 plus a2, 1 plus a3, so on. Now, if this has to be equal to 5, all these numbers should be 1, except only one number, one of these numbers has to be 5. Whether this can be 5 or this can be 5. 5 can't be written as some 2 into 3 or something. It can't be written like that, right? Because 5 is a prime number. So 5 can be written only in 1 into 5 and nothing else. So only one of these numbers has to be 5 and everything else has to be 0. Only one of these guys has to be 5. All the other numbers have to be 0. Meaning, some AI plus 1 should be equal to 5. All other aj plus 1 should be equal to 1. That's how we'll get 5 into 1 into 1 into 1, so on, equals 5. There is no other way we can get 5, correct? Alright, why? Because 5 is a prime number. Instead, if it was 4 positive divisors, there would have been 2 ways we could have gotten 4. Alright, for example, we could have gotten 4 by a1 plus 1 equals 2, a2 plus 1 equals 2, for example. For example, we could have gotten 4 by all the numbers of the form p1 into p2 or of the form 4 have 4 divisors, because 1 plus 1 into 1 plus 1 equals 4. Straightforward. Because we also p cube 1 plus 3 equals 4. And these are the only possible cases for 4. That's why. Exactly. Raja says 2 into 2 and 1 into 4. There are two ways to write 4 as a product of two numbers. There are two ways to write 4. Yeah, as a product of two numbers. 1 into 4 and 2 into 2. I choose the number 5 because there's exactly one way, which is p to the power 4. Like 1 into 5. P to the power, all numbers p to the power 4 have 5 divisors, which is 1, p, p square, p cube, p power 5, p to the power 4. So it is sufficient to add all numbers. So since n is up to 10 to the power 12, fourth root of n would be up to 10 to the power 3. So it is sufficient to add all squares, all fourth powers of primes under 10 to the power 3. That's it. Very straightforward. And then we can check it if it's there in the bucket or not. Instead of adding, we can make max n as 1e3 because 10 power 3 power 4 is 10 to the power 12 into I. I need to make this long because this will overflow. Now check 5 divisors. That's it, and that's it. This is the only change you need to make. All right. It's going to happen super quick. All this is going to be 1000 into max n is 10 cube. So it's going to be 1000 into log of 1000. And for each test case, checking is just checking if it's there in the bucket or not. Any doubts so far? I'll explain it again if you have any doubt. Ask me if there are any doubts in the live chat. I'll explain it to you. Any doubts, fellows? With one small change, we can, like, the question which seemed overwhelming at first to some of you, it's now better. It's now like very simplified. Radha asks, there's no plus, it's I into I into I. This is I power 4 basically. This is I power 4. All primes, I'm taking all primes. Previously I explained, I inserted inside my bucket, inside my good bucket, where it has all numbers which have 5 divisors, and it had only the numbers which had 5 divisors. In that bucket, instead of inserting square of a prime, I'm inserting the fourth power of a prime, because the fourth power of prime will have 5 divisors. Or rather, this is for 5 divisors, right? For 4 divisors, maybe we could have done that, but for 5 divisors, like if a number has to have 5 divisors, it has to be of the form p power 4. Correct? It has to be of the form p power 4, and that's it. There's no other number which has 5 divisors and is not of the form p power 4. That's why we are adding only p to the power 4 into our bucket and not p cube or anything else. Is that clear? Like, do ask without any hesitation. Here to answer your questions. Awesome. If there are any questions, please ask me. You'll be, in a lot of number theory problems, you'll be using Sieve a lot. Like, it covers a good portion of number theory problems. That's why a lot of my last 2 lectures were on this itself. This problem, the brute force of this problem also included the brute, like iterating up to root n. It covers that too. It covers both the parts. All right. Is this clear? Do let me know if there are any doubts in the live chat. And if you're watching this, don't forget to subscribe. So if you've understood it, like do drop a yes, I've understood it in the chat so that I know that you're understanding it. But if you have any tiny doubt in this code, like any bit, I'm here to explain it to you. Sairish asks, I wanted to receive your lectures for beginners. What should I do? What do you mean? Can you frame your question a bit better? Like, I'm unable to comprehend what it means. Can you be more specific? These lectures are for beginners. These lectures are for people who are just starting competitive programming. All right. So you don't need any prerequisites. You have my lectures here for free. There is no need to like receive it or something. It's here. It's right here, and it's going to be uploaded on this channel. So if you subscribe to this channel, you'll have those lectures for free. Got it? Yep. Thanks for the responses. So, all right. Now, let's go to the next question. Let's go to the next question. So the next question, it's going to be a little hard question. It's going to be a bit hard, but don't worry. If you've understood this question and if you've understood if you've attended my previous lectures, the next question will just be a breeze. The solution is going to be a breeze. Like you'll understand the solution and it's also going to be a bit about number theory and primes, and prime factorization, but it's important to know what's going on. Okay? Looking at the lectures. All right, let's move on. Oh, yeah. This is the next question. Given a number A, count the number of right angle triangles in which the length of the non-hypotenuse edge is A. All right. All right. The question is a bit long, so I'll explain it to you what it means. Where's my pen? Okay. Yeah. So, what is a right angle triangle? A triangle in which there's a right angle. That's it. And count the number of right angle triangles in which I just made a mistake here. Number of right angle triangles in which all the sides are integer sides, like A, B, C. All of them are integers. A, B, C. ABC, where A square plus B square is equal to C square. All of them are integers. Right angle triangle, I just forgot to add integers with integer length. For example, we know the famous right angle triangle, which is 3, 4, 5. This is the smallest right angle triangle with integer sides, right? In terms of perimeter, area, and max hypotenuse, or whatever you want to call it. 3, 4, 5. Because 3 square plus 4 square equals 5 square. Straightforward. All right. Now, we know that one integer side is A, and this is B, and this is C. But we are given only A. We want to calculate the number of triangles where A is one of these non-hypotenuse sides. For example, we want to calculate number of B comma C. Like if you fix A comma B comma C, if you fix the sides of the triangle, you're fixing how the triangle looks, right? It's very, like if we say the sides of the triangle 3, 4, and 5, we know how the triangle looks. So we need to find number of B comma C, where A square plus B square plus C square, so A square plus B square equals C square. All right, that's the question. Like, so given A as input, You need to find number of b comma c where count of b comma c where a square plus b square is equal to c square. That's it. For example, if you have so Sharish asked, what's the time of this class? It's going to be about at this time, about 12 p.m. to 1 p.m. ish. Do follow this CodeBeyond channel, and you can see the community posts when this class happens. Okay. All right. If we no, just a clarification. A is not a hypotenuse. A is an integer side. This is not A. This is not A. This A can be only a non-hypotenuse side, meaning we just need to find the number of solutions A square where B square minus C square given A. For example, if A is 5, A equals 5. One second. If A equals 5, then number of solutions for 5 square plus B square is equal to C square. Number of B comma C. One example is 25 square. One example is B equals 12, C equals 13. That's one example. Correct. Another example is, what's another example? I guess that's the only example. For example, 6 square plus B square is equal to C square. One example is 13 square is 169, 12 square is 144. 169 minus 144 is 5 square. So we need to find the number of B comma C that satisfy this. All right. How do we do this? Like, is the question clear for everyone? Is the question clear for everyone? Are there any doubts? Okay, got it. Let me know if the question isn't clear. Harini says the question is clear. Awesome. Yes, 12 comma 13 is a solution. All right. Now, given A, let's rearrange the equation. A square plus B square equals C square. Given A square, you need to find the number of C comma B which satisfy this. You're given this input. Pawan says the question is not clear. All right, I'll explain it to you again then. Input, I'll write it clearly in terms of mathematical terms. Input is A. Output, count number of B comma C, where B and C are integers, positive integers, where A square plus B square is equal to C square. All right. All right. Yep, sorry about that. Misunderstood you. All right. Now, A square is equal to, we rearrange this question. Rearrange the equation. C square minus B square. All right. We know this. We know what this is. Exactly. C square minus B square should be a perfect square. A square is equal to C square minus B square. Now we write C square minus B square as C minus B into C plus B. This is the observation. This is the most important observation of this problem. And in fact, this will lead you to the solution. Now, A square equals C minus B into C plus B. So what do we get from this? If we have some factor of A square, what does this mean? Exactly. Raja Rajput says factorize. Exactly, that's how it is. This means C minus B and C plus B both are factors. right? So for example, if a equals 5, a square is equal to 25. 25 is equal to c minus b into c plus b. Correct. Now, 25 is also equal to 1 into 25. Say we call this 1. C minus b should always be less than c plus b, right? Because c plus b is 2b plus c minus b, and b is positive. So a positive number added to a smaller number gives you a bigger number. So c minus b has to be equal to 1. C plus b has to be equal to 25. Now, just write it down clearly here. 25 is equal to b minus, I don't know what the convention was. C minus b into c plus b. If c minus b is 1 and c plus b is 25, then let's solve this linear equation. C minus b equal to 1, c plus b equals 25. Now we add this and divide by 2. 2c equals 26. C equals 13. That means b equals 12. Alright, if we solve this linear equation, which you learned in high school, we get this. From here we get this. C equals 13 and b equals 12, which we just got it as a solution if you remember correctly. 13 square minus 12 square equals 25 square. And what's another solution? You won't get this for all factors, by the way. 25 equals c minus b into c plus b. My handwriting is bad, apologies for that. C minus b into c plus b. This is 5 and this is 5. This should not be equal. Since 25 is a perfect square, 5 into 5, this is not a solution because you'll get b equals 0 in this. C equals 5 and b equals 0, which is not a solution. That's the only edge case. For example, we take another number, 36. All right, 36. That's a equals 6. A square equals 36. Is equal to c square minus b square. Now, let's arrive at other condition. C minus. So if the factor of 36 is say a into b, let's call it x into y. That means c minus b equals x. C plus b equals y, which means c is equal to x plus y by 2, b is equal to x minus y minus x by 2. Pawan is saying this condition is always going to hold that c minus b equals 1. It is always, no, it won't always hold. It won't always hold. Like, it will give you a solution, but in some cases it won't give you a solution where all of them are integers. This is an example, for example. I'll get to that, but let's come here. I'll get to that part, why it won't. Because, okay, I'll just tell it to you now. If it's c minus b equals 1, if c minus b equals 1, then c plus b equals 36 in this case. So c minus b is odd and c plus b is even. What does that tell? Like, you won't get integer numbers. So c minus b and c plus b, they differ by an even number, right? C minus b plus 2 into b is c plus b. So this plus an even number is this. So if x is an odd number, y should also be an odd number. If x is an even number, y should also be an even number, correct? Which means that there will be some factors which won't give you an integer solution. I'll show it to you. So 36 is there. 1 into 36. Yes, both must be even or both must be odd. That's the exact condition. 2 into 18. 3 into 12. 4 into 9. 6 into 6. And the other ones are redundant. We should not consider 6 into 6 because we are getting b as 0, right? C plus b is 6 and c minus b is also 6, meaning b is 0. This is not valid. 1 into 36. C minus b is 1. C plus b is 36. Both of them have to be even, or both of them have to be odd. But one is odd and 36 is even. So that is wrong, because we will get fractional lengths of the triangle. But that is not a question. You should get integer lengths. Let's just take this. What will you get? C plus b equals 36. C minus b equals 1. Which means we get C is equal to 37 by 2. B is equal to 35 by 2. Not integers. Nope, they're not integers. While A square plus B square is equal to C square is satisfied in this. They're not integers. B and C are not integers. We want integers. For that, what we do is, both of them should be even or both of them should be odd. For example, in this case, 2 into 18 will work. That is, C minus B equals 2, C plus B equals 18. That is going to work. What will you get here? C equals 10 and B equals 8. If you solve that equation, you'll get this. So 10 square minus 8 square is equal to 100 minus 64 is equal to 36. C and B are integers. B square minus C square is equal to A square. Satisfied. Similarly, you'll get the, but 4 into 9 won't happen. Like, it's wrong because 4 is even and 9 is odd. 3 into 12 also won't happen. 3 is odd and 12 is even. All right. Now, what are the conditions that we have gathered so far? Yes, Raja was right. What are the conditions that we have gathered so far? We have A square. If we can write this as x into y, for all, and x should be less than y, where x is less than y, because we're writing the C minus B into C plus B. Man, my bad. A square is equal to C square minus B square. A square is also equal to x into y. X should be less than y. All right. Because if x equals y, then b will be equal to 0. Correct. X is equal to C plus B. Y equal to, sorry, mistakes, C minus B. Y equal to C plus B. Now, the conditions are x less than y and x comma y should be both even or both odd. Got it? Very simple. Awesome. Raja has a solution. Factorize, and both factors must be either even or both factors must be either odd. Like both must be odd. Any doubts in the solution? Any doubts? Do ask it in the comments, the live chat. I'll start coding, and I'll come back to the live chat again to answer your doubts. X less than y or x greater than y, like you can put one condition. Both are symmetric, so it does not matter. It's okay. Bunny says no doubts. Okay. Int n, C in n, C out, count of n. Now, LL, I mean, the answer is going to be integer, but like anything works. Count int n. This will return the number of solutions. So for int I equals 1, I less than equal to n, I plus plus. You can write I at till square root of n because x is less than y. We just write it as x instead of because that's how we discuss it. For int x equals 1, x less than equal to x into x less than equal to n, x plus plus. We are iterating till square root of n. Now, if x is a divisor, x equals 0, then what will y be? Int y equals n by x. All right. Now, if x less than y, I mean x is already obviously going to be less than y, but sometimes it can be equal to. That's why I put this condition: x less than y, and x modulo 2 equals y modulo 2. Answer plus plus. answer plus plus. Return answer. That's it. So for each factor, like for each pair of factors, x into y, here we know that x into y equals n. X into y equals n. For each factor, we checked x modulo 2 will give you 0 if x is even, 1 if x is odd. Similarly, y modulo 2 will give you 0 if x is even, 1 if x is odd, like y is odd. So if x and y have the same demand of modulo 2, and x should be less than y. That is the only condition and nothing else. But got it? At this point, xy is equal to c minus b into c plus b. Well, I crossed the border for my joke. So x into y is equal to c minus b into c plus b. X equal to c minus b, y equal to c plus b. All right. Now c is equal to x plus y by 2, b equals y minus x by 2. This will ensure, like, these are the solutions, but we don't have to list down the solutions. We just have to count how many solutions are there. That's what I did, answer plus plus. All right. If you want the solutions themselves, like if you want the b comma c, you can write int b equals x plus y by 2. Sorry. C equals x plus y by 2. Int b equals y minus x by 2. Simple, that's it. B and C are the solutions. You have A. This will ensure n into n plus, I used n instead of A, B into B is equal to C into C. That's it. Let's press return answer. All right. So this is slightly inefficient, but it tells you what the logic is. All right. Any doubts in the solution? Radha says for all also we have to check. What do you mean? Like we don't need to, because if x is odd and y is odd, that's also covered. If x is odd and y is even and y is even, that's also covered. We can see that if x is even, and y is odd, this will be equal to 0 and this will be equal to 1, which means it won't go into this loop. Answer won't be added by 1. Hence, we don't need to check additionally. All right. Any doubts so far? Drop it in the comment section. I'm monitoring it, like in the live chat. I'm actively looking at it. Or if everything is clear, please tell me if everything's clear. Or if you want me to go through it again, I'll go through it again. Whatever it is, like, can you please drop it in the comments, live chat? Is everything clear? Or is that a doubt? Raja says everything is clear. Gaurav says everything is clear. Awesome. Look at the code, and if you want to work out examples, I can, if you want, I'll just go through it once just for clarity. I want to be sure that it gets into your head. Like I'll just revise everything again. You were given A. We wrote it as A square equals C square minus B square. And this can be written as C minus B into C plus B. That means C minus B is a factor and C plus B is also a factor. And this can, which means they're factors of A square. And A square can be written as X into Y, where X is C minus B and Y is C plus B. So given x and y, we just factorize a square. We have, yeah, yeah. Wait, I just made a small mistake. Like it's not n, it's up to n square. Uh, like up to n square, sorry. Int, I just long limit and long n into n. This small mistake. It's just this. That's it. We need to iterate till n square, right? If you want to factorize n square, we need to iterate till n square, not log n. Sorry. You need to iterate till limit. This is n square basically. You need to factorize n square, not n. Got it. Just this tiny mistake over there, but everything else is fine there. N square, yeah. Raja, yeah. Correct. Well, I can. I mean, one second. I don't have bit/std or C++ here. Like it's there on my other user. I shall prepare my computer to execute it next time, but forgive me this time. Hope that's okay. I just need to make this long as well. Yep. And these two of them as long as well. But otherwise, rather forgive me this time. I don't have the libraries right now. But I hope you got the solution. Logic. I'll prepare my computer to prepare for what you say, executing the program from next time. I hope things are clear right now. I have a tiny exercise for you. It's an exercise. Do try it out. So here's the exercise. Do let me know if there are any doubts so far. I'm here to answer. So this is for a single A. If you have 10 to the power 5 test cases, how will you do it? For a single A, we are iterating till root of n square, which is again, you're iterating x till n. Might as well write this as n. Right, you're iterating till n. We're iterating this till root of n square. Correct. Now, the complexity of this is, for a given n, the complexity is O of n. O of n. We are iterating till n and we are checking. All of this is O of 1. Constant time, so O of 1. But we can do that for one test case. How will you do that for 10 to the power 5 test cases? How will you do that for 10 to the power 5 test cases? 10 to the power 5 10 to the power 5 into 10 to the power 5 is 10 to the power 10. And your computer won't run in time. How will you do that for 10 to the power 5 test cases? Think about this problem. Yes, exactly. For 10 to the power 5, this solution won't pass at all. Exactly. For 10 to the power 5 test cases, won't pass. I give you the logic. Now I want you to do it on your own. It's a hard problem. I want you to give it a try. Give it a solid try. You know the logic. And I'll give you an additional hint. Try to prime factorize using Sieve and do something about it. All right. Try to work it out and try hard. All right. All right, fellows. This is the, like, I hope you enjoyed the class. I hope you understood each bit of it. If you didn't understand, like, I'll come back in the next class, and if there are any doubts, I shall explain it to you. Like, if there are any doubts. Raja says it's going to take around 5 years. I don't think it'll take 5 years. It's going to take about 2 to 3 minutes. All right. Remember that a year has about, I think, I don't know. A day has about 10 to the power 5 seconds, so you're still fine. A year is going to have 10 to the power 8 seconds, and this is going to run in within a day for sure. So, all right. All right, see, if you haven't subscribed already, do subscribe it. Tomorrow we don't have a class, so I'm relocating to a different place in like 2 to 3 days. So I'll be off for a while because I need to pack and stuff. But once I come back, it's probably going to be there in like 4 to 5 days, and I'll explain the solution then. Thank you. Stay tuned. All the best for your weekend and stuff.